All right, let's take a look at the effect that our mean, our standard deviation, our sample size, and our confidence level have on the width of the confidence interval, on the margin of error. We have no control over what our sample mean ends up being. So we don't really care about the effect that that's going to have. We have no control over the standard deviation of the sample or of the population. So we really don't care about that. We're going to worry about what effect our sample size and our confidence level have on the width of the interval. Again, the width of the interval is just another way of saying the margin of error. Z is determined by the confidence level that we have. And that confidence level is determined by the context. If we're doing a research project just for kicks and giggles, we don't really care that much about our confidence level. So we might choose an 80 or a 90% confidence level for that. But if we're going up against McDonald's or Subway, somebody that's got a lot of lawyers, we really want to have our ducks in a row. So we really want to have a high level of confidence. So we really don't have control over this. The context of the situation is what determines the confidence level we need, and that tells us what Z is going to be. So we don't really directly control that very well either. So the one thing that we can do to get a better margin of error, a smaller margin of error, a more accurate estimate, is we can control the sample size. And if we know what we want for a margin of error and we know the other factors involved, like we know the confidence level we want, so we know Z, we know the standard deviation of the population, or at least have a reasonable estimate of what it might be, and we know the margin of error we want, we have a formula here that'll give us how many people we need in our study or how many data points we need in our study in order to get the margin of error that we want. So let's do one real quickly. Let's say we're looking at IQs again, because the numbers are nice. And we know the standard deviation is 15. And let's say we want 95% confidence. That means that our Z is going to be that 1.96. And suppose we're looking to find the mean IQ for Jefferson College students, and we'd like that to the nearest 1 point. Suppose we would want our margin of error to be 1. Well, then we can use this formula here. The number of people we're going to need in order to accomplish this is going to be 1.96 times our 15 divided by our margin of error of 1. And then we'll square that whole thing. And that's a really easy calculator deal. 1.96 times 15 divided by 1, which you don't really need to do. And then we would need to square that. And we'll get 864 data points. That's how many we would need in order to get the results that we want there. That's really terrible. But you get the idea. If you know roughly your standard deviation and you have, you know what your confidence level needs to be and you know the margin of error you want, then you can calculate how many people or how many data points you would need for that. Let's look at our other situation. We had the commute times, and we had an average, which didn't matter, of 25. We had a standard deviation of 10. We only really care not that much about it, so 90%, which gives us 1.64 for Z. And let's say we want our margin of error to be, let's go for 5 minutes. We want to know the average to the nearest 5 minutes. So we're looking at our commute times again, standard deviation of 10, 90% confidence level, so Z is 1.64, and we want a margin of error of 5. So we can multiply 1.64 times 10 divided by 5 and square. 1.64 times 10 divided by 5 gives us 3.28. And then we square that and we get 10.75. So all we would need, right, is 11 people in our study if we don't need to be that confident and we can have a fairly wide margin of error. One more thing we need to discuss from this particular topic is the specific effect that n has on our on the width of our confidence interval. So if we have more people in our sample, then what's going to happen to our margin of error? If we have more people, that gives us a better result. We're going to have more confidence and we're going to be able to narrow down that confidence interval. So if we have more people, then the margin of error will get smaller. If we have confidence, if we have more confidence, if we increase our confidence level, what do you think is going to happen to the margin of error? Give you a second to think about that. If you've got more confidence, are you going to have a bigger interval or a smaller interval? More confidence actually requires a larger margin of error, because remember, what we're trying to do is to make sure that we capture the mean of the population within our interval. So if we want to be more confident that we're catching the mean, we need to cast a larger net, and that means a bigger margin of error. You definitely want to remember those for the test. Talk to you later.